Hello everyone, I'm the leader of our group, Arc Linux. So, my name is Harishraj Raghavan. So, the individual part I did was web server.
Hello everyone, my name is Muhammad Shafiq bin Abdul Rahman. I am one of the team member in this group, and my part that I have done is the database server part.
Good day, everyone. My name is Mohamed Babin Nuradi, and same with Tafiq, I'm also part of this team group. My part for this project is doing the SFTP service.
Hi, my name is Mohamed Fahimi Beroza. I'm doing the DHCP for this project.
Hi, my name is Harishraj Raghavan. My matrix number is B1510333. I'm from 1 Buxy S1G2. So, as the leader of the group, first of all, I would like to talk about task 1, which is designing and configuring a private virtual network using an internet networking option in virtual machine. First, I will verify the hostname of our server virtual machine, which identify this machine uniquely on the network. So I am typing in the command hostname. So as you can see, the hostname is set to our configured server name, confirming that the server has been properly identified on the network. Secondly, we're gonna see about correct IP for server. I will check the IP address that has been assigned to our server. So I'm using the command IPA. So as you can see, our server is configured with a static IP address 192.168.1.254 on the Internet Network Adapter. This is the address that all our services, DHCP, SFTP, web server, database server rely on to be reachable by clients. Okay, now the third point. Now I will explain the difference between a static and a dynamic IP address. A static IP address is one that is manually configured on a device and does not change no matter how many times the device restarts or reconnects to the network. We are assigned a server static IP of 192.168.1.254 specifically because it's need to be consistently reachable at the same address for all our services to function correctly. On the other hand, a dynamic IP address is automatically assigned by a DHCP server and can change each time the device reconnects to the network. Our client virtual machine uses a dynamic IP, which is automatically handed out by the DHCP service running on the server. This setup reflects a typical real-world network where servers use static IPs for reliability while client devices are given dynamic IPs for convenience. Now we're gonna see about the fourth point. Server can connect to the internet. Finally, I will confirm that our server is able to connect to the internet even though it is operating within a private internet network. So I'm typing in the command ping -c for space 8.8.8.8. As you can see, the server successfully received replies from Google Public DNS server, which confirms that has internet connectivity. This is possible because the server virtual machine uses a NAT adapter alongside the internal network adapter, allowing it to reach external network while still serving our private internet clients. So to summarize, we have successfully configured our server with a proper hostname and a static internal IP address of 192.168.1.254. We explained the difference between static and the dynamic IP addressing and demonstrated how our server applies both concepts within this project. We also confirm that the server maintains internet connectivity through its NAT adapter while still functioning correctly within our private internet network. This concludes the general network configuration component of our project.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan Hakimi bin Razak, and I'm doing the DHCP for this project for our group. Okay, so today I'm going to demonstrate our DHCP configuration and live testing deployment using virtual machine. So before running the commands, the main purpose of this setup is to automate network configuration instead of manually assign static IP address, netmask and gateway to every client on the network. Our server is automatically managed and locate and list all the network setting dynamically. So first, we need to verify our DHCP is active or healthy for server side. I will type the command so we can test the DHCP is active or not. So the command is sudo So here in our ArchLight server, as you can see from the output in the screen, the status is highlighted in green as active, which is running. This confirms that the background of the DHCP service is successful. So this step is very crucial because if we make any mistake like syntax error or typos in our configuration file, the system service would crash or show as failed. So below the status, you can also see the live system logs showing that the server daemon is up, running and actively listening for incoming IP requests on our network interface. Okay, now we're gonna switch to our client, which is Linux client. But first, I will type the command to delete the client historical network list database. Okay, so this command will firstly delete the client historical network list database. We need to do this completely to wipe out any previous network cache. If you don't clear the history, the client might simply request its old cache IP address from its memory instead of initiating a fresh transaction with our server. Deleting this will ensure our live test is 100% clean. Okay, so next, I will show you the live IP request by running this command. Okay, so the -V flag stand for verbose, which force the daemon to show us the exact packet happening behind the scenes. Looking at the logs that just populated on the terminal screen, you can clearly see the core DHCP negotiation step. It shows DHCP discover, which means our client is broadcasting a message to locate an active server. Then it shows DHCP offer, where our server offer an available IP address. This will follow by DHCP request from the client to claim it. And finally, DHC pack from the server to acknowledge the list. Okay, at the very bottom line, it states bound to 192.168.1.6. Okay, so this output means that entirely handshake completely successful and the client has officially rented this IP address. To confirm and prove that the client network card has officially applied this configuration, I'm going to type IPA to list all the operational network interface. Okay. So if we look closely at the interface number 2, which is and post 3, the primary configuration line explicitly read INET 192.168.1.6/24. So this confirm absolute success. So our client successfully received the IP address 0.6. This perfectly validate our server behavior because 0.6 fall exactly within our configured IP pool range of 0.6 to 0.10 that we said earlier. Yeah. This means every single test packet is successfully transmit and received, proving that local communication between our client and server is fully stable and functional. So, on other hand, if we attempt to ping an external domain like google.com, the terminal immediately throws a temporary failure in name resolution error. This failure is actually the exact expected result we want to see. It proves that our virtual network adapter layout is properly isolated as strict host-only network. So it confirms that our client and server communication flawless locally, but are safely sandboxed from the public internet. Okay, that's cover our entire live terminal demonstration for DHCP service. Thank you.
Assalamualaikum everyone. Today for my part the project group for the group project, I'll be doing showcasing our second part of our service, which is the SFTP or the SSH file transfer protocol. So what is SFTP, or what are the uses of it? So SFTP is actually a secure method for transferring files between computers over a network. So unlike FTP, which is the file transfer protocol, SFTP use the SSH service or SSH encryption, which protects the data, username, password, and passwords during transaction. Pretty much what does it do is that it encrypts our files before transferring, thus improving the security. So the purpose of SFTP are to secure the file upload and download, for remote file management, data protection via encryption, and finally for user authentication using the SSH, because for the SFTP we need to create a new user first. Next part is I want to test whether the SFTP is in the server or not. So in order for we to test that, we can test it from the client, but the way we do that is by trying to connect from the client into the server via SFTP. So, but before we do this, we first want to create a text file for the purpose of which we will use for the next part after this. So the first thing that we want to do is to, like what I said, to create a file before we enter the SSH. So we do echo sf test. So this is what I do for so first we echo the text I want to. You can put any text you want but for this one I just write this, which is this testing for the SFTP service. Alright. Then we put the text that we have tested into the SFTP test. So before we do before we enter the server via SFTP, we first want to. So what I did is first create a text file with you can put any text you want in here, but I just put this one, which is this is a testing for the SFTP service. And then after you do that, you put in. So after that we put the text into the SFTP test.txt. Alright, next we want to enter the server via SFTP. So what we want to do is use the SFTP command, I believe. So SFTP, oops, typo. We're gonna do the alright, now it asks for a password, so we put in the password and yes, we are connected. So now that we are connected into the server, which we can tell by the IP address, which is 192.168.1.24. The part where it says that it's connected to 192.168.1.254, that means that we are connected into the server, and this proves that the SFTP service is available in the server. Alright, so now we are going to test the uploading file and the downloading file, both uploading from client to server and downloading from server to client. So let's do it. So alright, but before we do the uploading and the downloading, we first want to check the contents inside the SFTP directory. So what I'm gonna do first is to check the following. So the first directory, and then okay, so after entering, so why do I did this is to check like I said, to check the contents in the directory. So first pwd, I want to check what is our current working directory, or our current remote working directory as set in front in the script. So in we said our remote working directory is slash. We want this because like we set up before, the directory or the root directory we want is for the slash, which is the root shell directory. So this one is fine. And then I put the ls is because I want to list all the like directories of file in the SFTP. So after I done the command, I see that there's only uploads directory, which is exactly what we want. So next I'm going to change the directory into the uploads, and alright, so you can't really tell that you are inside the new directory, but so when you change any directory inside the SFTP, you need to make sure that what directory you are in right now. So if you want, you could use the pwd again, but I'm not doing that. Alright, so now we can begin to test the uploading from client to server. So what I'm going to do is put the text file that we created, so sftp test.txt, and then alright, so it's finished. So after I've put the sftp test.txt file into the SFTP, so pretty much what I did here is that for SFTP there are certain commands that you have to use in order, because SFTP in this, at least in our service, is not really, it is not a shell, I believe. So there is only a limited amount of command that you can use. So one of them is put. Put is pretty much like the name suggests, name meaning. So we put a file inside the SFTP or in our current directory, in this case in the uploads directory. So because we set up the directory to be able to, I believe, read, write and execute inside it as user of our current user, which is Bakso1213 GRP or group. So that's why we're able to upload our file into it. So when we see inside there's the upload, see it's uploading the file, and then you can see /uploads/sftp test. So this means that it's uploading into the uploads directory, and then it's done. And then what I'm going to try is to see whether it is inside the directory. So if I put ls, and then as you can see, it is in there. There's also another file here, which is the test file, but that is from another test, I believe, in the report. Alright, so after we have done uploading, we are going to try downloading. But for downloading, what we're gonna do is try to re-download the SFTP test file from the SFTP server. So, but before we can do that, we first need to delete the file, the original file, in our client. So in our client VM. So we will first exit the SFTP. So first we want is to exit the SFTP service or server. So we exit, and then we will remove the file. So alright, now that I've removed the file, we will re-enter the SFTP server back. So we are gonna do that. Then enter the password, and then change directory. Alright, now that we are back in the upload directory in the SFTP server or service, we will now try to download the file using, I believe, put and then get. Yes, I believe get. So get. Alright, so it is finished fetching, and then so after we use the get SFTP test file, it will try to fetch the file from the upload directory, and then you can see the 100% the size, the file, the speed second, and then the time. So that's pretty much how you download the file from the SFTP using get. So now we are going to check whether the file is downloaded back into the original VM or the client. So we will first exit the SFTP, and then after we exit, we're gonna check the directory. So ms, and then as you can see, the SFTP test.txt is in the contents of the home directory, I believe, home directory. So this pretty much proves that we are able to successfully download the file from the SFTP server. So now we are gonna check the content of the file to see whether it has changed or not. So okay. Then contents. So when we run the cat command on the file, we can see that the text inside is still the same as the one above. So this pretty much confirms that we are able to successfully download the file from the SFTP into the we are able to successfully download it. So pretty much what we can learn from this, or so pretty much what we can learn from it is that the SFTP service in our project is able to work just fine, and we're able to do both uploading and downloading, which is for uploading we use the put command in the SFTP server, and when we are downloading a file we can use the get command to get the file from the server, SFTP server, back into the client. So in conclusion, pretty much this demo is able to show that our project, or at least our system in our project, is able to connect into the SFTP service and use them effectively, which is via uploading and downloading. That is all for my part. Thank you for listening till the end, and I hope you guys who are watching are able to understand.
So now I'm going to explain to you about web server, which is my individual part task tree. So first of all, I'm going to explain the usage of web server. For this project, we are using Aperture 2 as our web server, APACHE2. It's an open source web server software that runs on our Linux server virtual machine. Its main job is to listen for incoming HTTP requests on port 80 and respond by serving HTML pages to any client that requests them. In our network setup, the server virtual machine is configured with a static IP address 192.168.1.254, and Aperture 2 runs as a background service on that machine. So whenever a client on a same internet network sends an HTTP request to that IP, Aperture 2 receives the request, processes it, and returns the web page we have configured. This is essentially how every website on the internet works, just on a much smaller private scale within our network, virtual network. So secondly, I'm going to explain how the testing is being done. To test that the web server is working correctly, we will be using a command line called curl, C-U-R-L, run from the client virtual machine. Since our client virtual machine does not have a graphical desktop or browser installed, curl gives us a way to send an HTTP request directly from the terminal and view the raw response. When we run curl pointed at the server's IP address, which is 192.168.1.254, it sends a GET request, GET request, to port 80. If Aperture 2 is running and configured properly, the HTML content of our custom page will be printed straight into the terminal. This is a reliable way to confirm two things at once: that the server is reachable over the network and the Aperture 2 is running serving content correctly on port 80. So to test that, I'm going to show web page from the client. So I'm using the client virtual machine and going to use curl to send an HTTP request to our server at 192.168.254 to confirm that the web server is reachable and responding. So in the client terminal, I'm going to type the command curl http 192.168.1.254. So this is the HTML we did before. So you can see it. This shows how our client able to successfully reach the server over the network and receive a response from Aperture 2. So now I'm going to design a simple web page. I'm switching to server virtual machine. So I'm going to type the command sudo nano/war/www/html/index.html. So this opens the file. This is the default webroot directory of Aperture 2. Automatically looks into when it receives a request. So this is what we wrote before. So now I'm going to create a new one by deleting them. So I'm using Ctrl K So after I'm deleted everything using Control K, now I'm going to type in the new HTML. So now that I completely wrote the new HTML, I'm going to save it using Control O. Then I'm going to enter, then Control X to exit. Now I will display the file content directly in the terminal to confirm it was saved correctly. So I'm going to use the command cat /war/www/html/index.html. So as you can see, it shows it. I will now go back to the client server and run the curl one more time to prove that this is updated web page and it's now live and being served correctly over the network. So I'm typing in the command curl. As you can see, the output now matches exactly what we just wrote: our group name, subject code, member names, and server IP, confirming that the web page was successfully updated in the server virtual machine and is being served live by Apica 2. So to summarize, we successfully installed and configured Apica 2 as our web server on Linux Server Virtual Machine. We designed a simple custom HTML web page containing our group information and placed it inside the Apica web root directory. We then verified that the web server was active and properly listening on port 80 and confirmed from the client virtual machine using curl that the web page was being served correctly over the internal network. This shows that the web server component of our project is fully functional and meets all the requirements.
Hello everyone, my name is Muhammad Shafiq bin Abdul Rahman, and today I would like to present about my work that I have did before, which is the database server. As we know that database is very well known concept that we already learned in our semester 1. So database concept is more advanced when it comes in the Linux server, when we want to run the command in order to create the database, insert the queries, insert the rows, insert the data into the database. So let me introduce to you how I run my codes, my commands in the Linux server using the virtual machine on server and client. So first and foremost, let me give the brief explanation about what is database. So as we know that database is something that we're using for us to allocate all the data in one place. So it is called database. So for this project, we are using the MariaDB as our database server. It is because MariaDB is an open source relational database management system that is fully compatible with MySQL. It runs in our Linux server virtual machine and stores the data in structured tables. Clients on the network can connect to it remotely and run the SQL queries to create, insert, and to retrieve the data. Apart from that, MariaDB was chosen because it is lightweight, stable, and suitable for Linux-based server environment like ours. It uses a port specifically number 3306. I repeat, the port number is 3306 to accept incoming connections. In our setup, we have configured that MariaDB to allow remote access from client machines within our private network, and we have created a dedicated database and users specifically for this project. So, how the testing is being done? The database testing is being done. To test the database server, I will connect from the client virtual machine to the server's MariaDB instance over the network using the MySQL client tool. You will be more understand when I show the code. I will show the working. If the connection is successful, we will then run a few SQL queries to create a table, insert data, and read it back. This proves that the database is not just running, but it is also actually accessible and functional from another machine on the network. Before connecting from the client, let me first verify on the server side that MariaDB is running and listening to the correct port, which as I mentioned earlier, 3306, port 3306. This ensures everything is ready before I attempt a remote connection. So in order to verify the server is running, I need to type a command in the server virtual machine. So I will go to the server virtual machine. Then I run the commands to know that whether it is running an active server, that MariaDB is active or running on the server virtual machine. So the command is sudo systemctl status MariaDB. So it shows that the the status is active, running, and then the status is taking your SQL request now, which means that the MariaDB is running successfully in our server virtual machine. Okay, let's move it to the next step. So in order to move to the next step, I need to, after I configure that, after I figure it out that the service, the MariaDB is active and running on my server virtual machine, I need to confirm that it is listening on port 3306 which I have mentioned many times. So in order to know that, we need to figure out that I need to command sudo ss grep and then the port number 3306. So and it shows that here it is in the port 3306. So we are safe. And then for the next step, to connect to the database, I need to switch to the client virtual machine in order to connect to the database. So I just go to the client virtual machine here and then I run my code to connect to the database. But here I want to mention about a specific IP address that I have gained in order to connect to the database. It is because when I will switch the client virtual machine and I want to connect remotely to the database server, but I need the IP address in order to do it, in order to done it. So the IP address on my virtual machine here is 192.168.1.254. It may be vary for others. Then my database name Alright, this shows that welcome to the MariaDB monitor, comments and bit O/G, your MariaDB connection ID is 34. This all shows that we can start to command the SQL. So in order for that, let me confirm which database we are currently using. So in order to know that which database we are currently using, it's very simple. We just tell select database. So it has shown here that our database is Baksu1213DB. Then we want to know that is it how many users that are logging in. Confirm which user we are logging in as. So in order to know that, we can just select user. So we are logging in as the user Baksu1213. And then this is our IP address. User as the user. Alright. And then we move to the next command, which is we need to test queries. So run each with an explanation. I will do it in order to show that is it our database is accomplished or not, the working. So first I will show the tables that I have created. These are the 3 tables that I have created before in my working. This shows that I clearly are able to create a table in my particular database. And then when I want to go to the next steps, I can create a new table, which is I want create table. This is SQL command. So create table, I will just put test table number 3 to I'm just following the list, and then I will assign the ID using the int data type, and then the name I will use the varchar data type. The length for the varchar I will in as 50, And yeah, it already shows that the query is okay. So I want to show the tables. Is it the tables have been created successfully? How can I know that? By run this command. So it shows that the table tree has included in the table list. And apart from that, I want to run the next command. So we can insert some data into the particular table that we have created before. So let's run the command insert into test table 3 that I have created before, and I assign values for them. Okay, it showed that the query is okay, and I will insert another row. And another row also have been inserted successfully. So, and now I will retrieve all the data to confirm it was stored successfully or not. So in order to know that, I can retrieve it by run this command select all from table test3. Oh, sorry, I'm just test table 3. Okay, this is the two rows that we have inserted before into the table 3. Test table, test table 3. These are the two rows, ID1 hello from client and ID2 buy from client. So this shows that our SQL command had been inserted successfully and our database is running successfully in our Linux. Alright. So this shows that the client can connect to the database that have been created in the server. So apart from that, if I want to drop the table that have been created before that, I want to show you again the tables that we have created before. These are the 4 tables and the latest one is table 3. So I want to drop the table right now. So how you will see the changes? Okay. And then the table tree is out right now because we already dropped it. So I want to exit. I just type exit. So it shows the buy. We already go in the database. We already run the table. We already insert the data into the particular table, which is the test table 3, and then we already retrieve the data, whether the data has been inserted correctly or not. That also has been proven, and then I drop the particular table. That also has been proven, and then I exit from the comment section. So in conclusion, I would like to come into a conclusion that I have successfully did my part. Which is I have successfully installed and configured the MariaDB on my Linux server virtual machine. We configured it to allow remote connections by binding it to the correct network interface and granting the appropriate permission to our dedicated user. We then created a dedicated database and users specifically for our group project. From the client virtual machine, we verified the connection was successful and performed a full creating, inserting, select, and drop operations remotely that I have just did before. And the server was confirmed to be running and listening on port number 3306 before the connection was made. We have checked it before we run into the database. This proves that our MariaDB database server is not only installed and configured correctly, but it is also functional and accessible across the private network. The database component of this project is complete and working as intended. So I have done my part as best as I can. I hope doctor can understand what I have an explanation, and sorry if I have anything explained maybe not so good or not so fluent. I already try my best, and thank you for listening, doctor. Thank you.
So, Ifan, I have a question for you. So, you did the DHCP part for our project. So, I want to ask, what is the purpose of DHCP in our project?
Okay, so the purpose of DCP in this project is DCP automatically assign IP address to the client VM on the internet network. Without it, we would have to manually configure the IP on every client, which is inefficient.
Okay.
Irfan, I also have a query about your part which you have done about DHCP. You already done the DHCP, everything, but how can you verify that your DHCP is working?
Very good question. So to verify the my DHCP is working is on the client VM. We run IPA to check if is receive an IP address from the server DHCP pool. If the client has an IP in the range we configured, DHCP is working correctly.
That's a good explanation. Thank you, Irfan.
So Iqbal, I have a question for you. What is the difference between FTP and SFTP?
Right. So the difference with FTP and FTP. So FTP stands for File Transfer Protocol. Meanwhile, for SFTP, it stands for Secure File Transfer Protocol. From the name, we can already tell that SFTP means that it will make the file transfer more secure. So if we were to use FTP only, we will transfer the file without any intrusion or any type of security whatsoever. So the file will only be set as a plain text, and it can be set. So that might pose a risk to us. So by using SFTP, we first run the file over the SSH service, which will then secure the file, encrypt it, and thus allowing it to transfer more safely.
Thank you for your explanation.
Iqbal, I also have a query about your part, SFTP. In our report, there's a particular part that we do about the CRUD jail. I mean, we are not so familiar about CRUD jail in our operating system subject. So, how do we, why did you use the CRUD jail for your part? Can you explain me about that precisely?
Sure, I can. So, CRUD jail. So, what is CRUD jail is pretty much a specific directory that we use for pretty much like for jail, pretty much a place we put someone in jail, like, or contain. So that's pretty much what it does. It contains the file or the service to that one specific directory. So by using CRUD jail, we are restricting the SFTP user to the specific directory, thus preventing them from being able to access any other directory in the server. So by doing so, we are able to we are able to improve our server or service security, and pretty much, make sure the file transfer, so that when they use our service, it is only for the service purpose, like for the file transfer purpose, no any other reason.
Thank you, Iqbal. That's a good explanation. It's beyond my expectation.
Thank you.
Harish, I have a question about your part. On our assignment, we have already do about the VAR, WAR, and www, HTML, index.html. But I don't know what is the purpose of these terms specifically. Can you explain to me more precisely?
So the purpose of the /war/www/html/index.html is, so it brings us to the index.html file. So the index.html file is the default file Apica serves when no specific file is requested. When the client in the client virtual machine, when we run the curl http://192.168.1.254, which is our IP address, without specifying a file name, the aperture will automatically look for and serves index.html from the web tool. So that's the purpose of the index.html specifically.
I also have a question for you. How do you verify the Aperture is running on the server?
So to verify the Aperture 2 is running on the server, we should run a command in the server virtual machine, which is sudo systemctl status Aperture 2. So once we enter the command, many output will came out, and in a column called active, we can see it is active bracket running or not. So if the results show active running, we can conclude that the service is up and ready to handle requests.
Yes.
So that's how we verify the Aperture 2 is running on the server.
Shafiq, I have a question for you. So for your database, for our project database, why did you use MariaDB instead of MySQL?
Okay, to answer your query about why we use MariaDB instead of MySQL is because MariaDB is an open source fork of MySQL that is fully compatible but more lightweight and free to use. Apart from that, MariaDB is the default database server available on our Debian based system, so it is more accurate for us to use MariaDB instead of MySQL.
I have another question for you.
Another question?
Yes.
All right.
So for our project database, I wondered how are you able to, like, how do you allow for remote access to the MariaDB from the client? How do you do?
Okay, that's a good question. How do we allow remote access to MariaDB from the client is, by default, MariaDB only accepts the connections from the local host. We change the bind address in the configuration file to 0.0.0.0 and granted remote privileges to the database user. So this makes the client virtual machine can connect over the network.
Thank you for your explanation.
Welcome.
So that's all from us.
Thank you.